Hello everyone. I'm Vatsala and today I'm going to discuss about what I've learned from the course of Quantitative Technologies for Agribusiness Management taught by Dr. Sachin Jain. First we learned about statistics. Statistics is the study of a sample with which we can infer about the population. It is of three types: descriptive statistics, inferential statistics and perspective statistics. Then we learnt about mean. Mean is a number from which the distance from all the numbers is minimum. And variance. Variance measures how far a set of numbers are spread out from the mean. It basically measures the magnitude of a number from the mean. That is why we are using the square of the sum. Then standard deviation. Standard deviation measures the amount of a variation of a set of data values. In univariate data, we call it a standard deviation, and in bivariate data, we call it standard error of estimate. Now let us take example of normal distribution. In normal distribution, let us say we take in account the height of the students in a class. The mean height is given to be 175 centimeter with a standard deviation of 3 centimeter. This means that in a normal distribution, 68% of the population, that is 68% of the students, lie between one standard deviation, that is between 172 centimeter of height to 178 centimeters. 95.4% lies between 169 to 181 centimeters, that is 2 standard deviation, and 99.7% of the students lie between 3 standard deviation, that is from 166 centimeters to 184 centimeters. Then we studied about correlation coefficient. It is the measure which determines the degree to which two variables are associated. It ranges between -1 to +1. -1 correlation coefficient depicts that the two variables are perfectly negatively correlated. That is, if one variable increases, the other one will decrease by the same rate. And then there is zero correlation, that means there is no correlation between the two variables. +1 depicts that they are positively correlated. It means if one variable is increasing, the other will also increase. Let us understand this with an example. Here we take two variables, height of the building and number of the stories. The correlation between the two variables is found to be 0.95. This means the correlation is positive. That is, the number of stories of a building increases, the height will also increase. Then we learnt about confusion metrics. In confusion metrics, we studied about type 1 error and type 2 error. Type 1 error occurs when something was predicted false and it was actually true. Generally, there is 5% chance of type 1 error. And type 2 error occurs when something is actually false and it was predicted to be true. Therefore, type 2 error is more dangerous than the type 1 error. Then we learned about hypothesis testing. When we get the correlation coefficient, we also need to see whether the two variables are significantly correlated or not. For this, we do hypothesis testing. We have got a calculated value of correlation coefficient. We make a null hypothesis that there is no significant correlation between the two variables, and an alternate hypothesis that there is some significant correlation between the two variables. For this, we do t-test. We get a calculated value of t by the formula, and from the t table we get the value of t at the given degrees of freedom. If the value of t calculated comes between the negative and positive value of t tabulated, then we infer that the value of r is significantly equal to 0. That is, there is no significant correlation between the two variables, and also we fail to reject the null hypothesis. In autocorrelation, we check the correlation between the two series by determining one period or gap. It is used to check whether the next period is correlated with the previous period or not, and it is used to know whether the previous error can forecast the next error. In multicollinearity, if one independent variable affects the other, or the combination of two affect the third, then it is called multicollinearity. Then we learnt about game theory. A game has to be two-person zero-sum game, where the amount one wins, the other loses. For example, share market. Share market is technically a zero-sum game. A fair game is when the value of the game is zero. Let us take an example where there are two players, player A and player B. Given here is the payoff matrix corresponding to the revenues or payoffs of player A when he plays three strategies, A1, A2 and A3, and gets the revenues corresponding to the strategies of player B. Here we calculated the row minima and the column maxima. The one common point between the row minima and the column maxima is called the saddle point. Here 1 is the saddle point and the value of the game is also 1. It is not a fair game because A is gaining 1 and B is losing 1. Then we learnt about input-output model. This model depicts the dependencies between the sectors of the economy. Here the different sectors of the economy have different productions. One sector takes the output of another sector and uses it as its input. Hence we can find the ultimate external demand by the difference of the entire total production and minus the internal consumption of these sectors. So this was all in brief what we learned in the class of quantitative technologies for agribusiness management, and we learned a lot more, but to summarize it in a short period of time I could do this much. Thank you so much, sir, for teaching us.